Hey everyone, welcome back to Mathematical Learning. A couple of months ago, I did a video on a+bi to c+di, but I don't think the video quality was that good, so I'm kind of doing a rerun of that video. And I'm going to do it in two parts. So part one is about Demoivre's theorem. So some of you may already know about Demoivre's theorem, but in this video I'm going to derive it. So if you already know the derivation of this video, feel free to skip to the next video, which will explain the other part of the formula. So by exponentiation laws, a plus bi to the c plus di can be, you can break it up into two parts. A plus bi to the c times a plus bi to the di. And in this video, we'll be talking about this part. In the next video, we will look at this second part, a plus bi to the di. So first we want to solve a plus bi to the c. And c is some real number, of course. Okay, so let's see. Now what do we do? Okay. A plus bi. Firstly, we want to write it in a different form. We don't, for these purposes, this a plus bi form is not good enough. It's not wrong, but we may need to write it in a different form to derive this. So we're gonna write it in the polar form. So as you may know, actually, if you don't know this, you might want to revise polar forms. Like imagine this is an Argand diagram, A, B, and let's say I have this complex number. Let's say a plus bi, and then I've got my b component, my a component, and for polar coordinates, imaginary, real, right? And for polar coordinates, I can write this as theta, so I turn some theta, and r. Okay, so I write it in terms of r and theta. So r is actually equal to, well, this is a, because this is the real component, a plus bi, a. I write it as, using the Pythagorean Theorem, a squared plus b squared is r squared, right? You can take the square root of both sides, and I get r is square root of a squared plus b squared, right? A squared plus b squared. Then over here you have this a plus bi. Then I've got my imaginary real axis. I've got my r. Now what is theta? Well, we know this part is b, this part's a. Now this is not a very good theta. Now the tangent of this theta, using SOHCAHTOA, is equal to the opposite over adjacent. So tan theta is b over a. So theta is tangent -1, inverse tangent of b over a. So we'll write it here. R equals square root of a squared plus b squared. Theta equals inverse tangent of of b over a. Now when you're talking about rectangular coordinates, a plus bi, to polar coordinates, you would say a is equal to r cosine of theta. Now why is this true? let's look at an Argand diagram. This is theta. And this opposite side is B, adjacent side is A. And the cosine of theta is A over R. So cosine theta is A over R. So A, you multiply by both sides, is R cosine theta. Same with B. B over R, opposite over hypotenuse, is the sine of theta. So B is equal to R sine of theta. So B is R sine of theta. So over here, we have our a plus bi, right? So we have, let's see, a plus bi. So we have a is R cosine theta plus R I sine of theta. And this is a plus bi. And obviously R is root a squared must be squared. Theta is inverse tangent of B over A. Alright, we're almost done. So R, right? This R, we can take it out. R cosine of theta plus I sine of theta. Now, when you look at this, I haven't substituted R and theta yet, but I will soon. If you look at this, just the cosine theta plus I sine of theta, this is actually Euler's formula. This thing is equal to e to the I theta. And I will prove that in a later video. Just so that you know, e to the I theta is cosine theta plus I sine theta. Okay, so we have R e to the I theta. This is a plus bi. Don't forget what R and theta are. We'll substitute them in later. Now, we want to take this to the power of c. And how do we do this? Well, we take R to the c and multiply it by e to the I theta to the c. That's how you do. You can multiply them together. Exponentiation, right? And e to the I theta to the power of c is equal to e to the I c theta. You just multiply it. Obviously multiplied by R to the c. And now this e to the I c theta, you can expand it out as R to the c I sine of c theta plus cosine of c theta, and close the bracket. So this is a plus bi to the c. Now, what are R and theta? Well, R is square root of a squared plus b squared. If you can't remember why, you can go back to the start of the video and rewatch that. To the power of c times I sine of, what is theta? It's the inverse tangent of b over a. Okay, and plus the cosine of, it's c theta, right? Plus the cosine of c inverse tangent of b over a. Now this thing is called Demoivre's theorem. And this is the first part of the video. So we're going to use this formula and combine it with what we're going to do in the next video, and to get one big formula. So this is Demoivre's theorem. Alright, I hope you enjoyed the video. As always, thanks for watching. If you liked it, don't forget to like and subscribe and share it with your friends. Okay, thanks for watching and see you in the next video.